Thought I'd start there, kind of give you another heads up so you can do your homework. Whoa, what the heck happened?
What section?
This is the previous section, so 2.5. And I just wanted to show one more example of graphing a strange thing. Oh, what can we do? That did. So I want to take the base graph, in this case x squared, and the base graph of x squared looks something like this. It has a point at the origin, and it looks like a parabola. What do all these little pieces of this g of x tell me to do with that x squared? Well, what's the negative 2 at the end tell me to do? See if you remember. Flipping back. That's not bad. It's not bad. At least you took notes. You can look at them. Negative 2 on the back end. Is it affecting the x? Is it affecting the y?
It go down to, right?
It goes down to. It's affecting the y values. So this right here tells you you're going to go down to. What does the plus 3 do on the inside with that x? Well, first of all, is it affecting the x's or the y's? It's directly affecting the x because it's on the inside. Which way is it moving? Moving left, opposite direction. So it's going left 3. What's this negative doing? Flip over horizontal. If you do it first, it would be flip over the x-axis, but I always do it last, so I flip over a horizontal. All right. What's the 2/3 do? Well, that's the last thing we're going to deal with. So generally, what does it do? You only have two choices: closer to the vertical, closer to the horizontal. Horizontal because it's going to come down. Yeah, it's going to be shorter. So closer to the horizontal. All right. So that tells us what we're going to do. Now we just have to do it. Not a very pretty graph, but it will do. Anybody remember the first thing I do? It's only been like a week. I move things. I move my axes first. I move the x-axis up and down depending on which way I'm going, and the y-axis left and right depending on which way I'm going. So because I'm going left 3, I'm literally going to take the y-axis and move it over 3 units. These are called imaginary axes. All right, what do I do with the x-axis then? The y-axis is coming left 3. The x-axis is going down 2. And if you think about it, this one has an equation of x equals negative 2, and this one has an equation of y equals negative 3. Okay. What point do I plot? Well, if the origin is the normal point for x squared, it's going to go left 3 and down 2. Well, if I go from the origin left 3 and down 2, where am I? Well, I'm at the intersection of these two imaginary axes. So that's your first point you're going to plot. Right at the intersection. That's why I like putting them there. Plus, it gives you guidelines for vertical and horizontal. All right. Now this thing is going to flip. So instead of facing up, it's going to face down. But 2/3 is going to be the last picture I draw. So the first one you draw is without the 2/3. And you kind of say, well, this is what it's going to look like. It's a parabola, and it's facing down. But that's not going to be my final picture. Now, the 2/3, you said that's closer to the horizontal. So if I'm sitting at a point over here, which way is closer to the horizontal? upwards. Number 1 or number 2 would be number 1, of course. So we would want this part of the graph to be here. What about on the other side? Over here?
Yeah.
But would that be closer to the horizontal?
No, so it would get wider.
You need to get wider. So if you have a point here, getting closer to the horizontal is number 1 or number 2? Number 1. So your graph is going to be out here someplace. It gets fatter. It's fatter. So if it was 3/2, it would get thinner. That's another way of looking at it. So that would be the graph of g of x, a solid line graph. And that's how I ask it on the test. I'll say, graph this thing without the 2/3 as a dotted line, graph the whole thing as a solid line. So this is the picture I'm going to be looking for on the test. So far, we have just been playing with functions. We are done playing. Now we're going to get serious with them. What else can we do to a function? That's what today's lesson is. 2-6. Combining and composition of functions. Now the reason that this section is so hard is there's so many pieces that go with it. The first piece is going to be finding the domain of a function without the graph. The graph usually helps because looking at a picture you can kind of figure out where it's going and where it's coming from. The equation of a function is a little bit trickier and you have to be very careful. So there are only 2 things you have to know about the domain of a function. Number 1, you cannot divide by 0. You all know this. It's just I have to kind of remind you that this happens in algebra too. You have to be a little bit more cautious with algebra. Numerics is easy. If I have 5/0, you know what's wrong. You just can't write things like that. But these things are going to be like 5/x plus 2. And you're going to not be thinking, when is the bottom going to equal 0? And you really need to. The second thing that you don't usually think about you cannot take the square root of a negative number. It doesn't give you a real value, so we won't be able to treat it as a real valued function. And that's all these functions are. So if you really want a pure definition, we're talking about real valued functions. Kind of gives you a hint that there might be things that are not real valued, which would be really nasty to work with. So out of these 2 things comes this idea of what does it mean to be a domain? What is a function's domain? So let's start with a simple example. Most commonly missed example of all. There's my function. And I'm going to say, find its domain. What is F's domain? Without graphing. So you go back to number 1 and number 2. Are you ever going to divide by 0 with this function for values of x that you are going to plug in? And the answer is no, because there's no division to begin with. Are you ever going to take the square root of a negative number? And the answer is no, because, well, there's no square roots in this whole equation. So what is the domain then? If you're never going to divide by 0 and you're never going to take the square root of a negative number, what kind of numbers can you plug in? Just 1 and 2?
Or,
All of them?
all of them.
Why wouldn't? Are we ever going to divide by 0? Are we ever going to take the square root of a negative number?
So it has to be all numbers above 0. Real numbers above 0.
All real numbers.
Just all real numbers above 0, so positive numbers only? What about negative ones?
Numbers except 0 and the square root.
What's wrong with 0?
You can't divide.
There's no division.
Well, put a 0 there.
0 is 0, negative 5. 0 plus 0 is 0 plus negative 5 is negative 5. I can do it.
So all real numbers other than 0.
But I can do
Then what are you
0.
dividing?
I'm being devil's advocate
I
here.
know.
I want you to really think about
I'm
this.
thinking.
Can you ever divide by 0? No. Can you ever take the square root of a negative number? No. So what numbers can I not plug in? Well, none. So that means I can plug in all. So the domain here, all real numbers. In interval notation, that gets written as negative infinity to positive infinity. I can plug in anything I want. It won't affect, I'll have answers for every number I plug in. I ignored you. Because you whispered it.
I didn't hear
I
you.
don't listen to whispering. The graph of this thing looks something like this. Remember what these arrows mean. It goes all the way to the left and all the way to the right. So the domain is negative infinity to positive infinity. But I need you to think about it more algebraically than pictorially. All right, so what about this one? G of x equals 4 minus 5 x all over 3. What is G's domain?
I'm gonna just go to 0.
Why not 0?
But you can't divide.
But is 0 ever going to divide this?
Okay, whatever all real numbers
Then all real numbers then, right?
Negative infinity to positive
'Cause-
infinity.
Are we ever going to divide by 0? No, this thing's always divided by 3. It's never going to be 0. Are we ever going to take a square root? No. So what's the domain? All real numbers. So the domain here is negative infinity, positive infinity. You can plug in anything into this. What kind of graph is this? You're all going to give me a heart attack, aren't you? This thing is a quadratic parabola. This one is... How do I know this one's a parabola? How do I know it's quadratic? Because it's squared. So what is this one called when the power is 1?
I had it too.
Okay, how about this? I'll rewrite it a little different. Ready? Y equals negative 5/3 x plus 4/3. What? It's a line. Thank you. It's linear. Why is it linear? Because it has a power of 1 on the x, and that's the highest power it has. Oh, it's like pulling teeth. Should have become a dentist. Actually, I think I would have enjoyed that.
Oh,
No Novocaine, though.
I can stick my face in people's mouths all
That'd make more money.
day.
My hands are too big to go in people's mouths. All right. So, how about this one? F of x is equal to x minus 3 over x squared minus 4. X minus 3 over x squared minus 4. Now, these two over here, they have a special name. These are called polynomial functions. And polynomial functions, their domains are always the real numbers. Negative infinity to positive infinity. Because polynomials don't have variables in the bottom, and they can't have variables inside of square roots. Remember the definition of polynomials? Did I ever give you the definition? I thought I did. Polynomials are a product of a letter and a number, and the powers have to be whole numbers. They can't be fractions or anything weird. This is not a polynomial function. This is called a rational function because it's, a quotient. Can I ever divide by 0 with this thing? Really? Think about this for a second. X can be anything. So, can X be anything that forces the bottom of that fraction to be 0? I can think of a number. Some number squared minus 4 equaling 0. 2 is one of them. What else? Negative 2. Because if you square negative 2, you still get positive 4. So what should you do with functions that look like this? Well, you take the denominator, you write it down, and you set it equal to 0. And you try to find out when denominators are equal to 0. Two ways of solving it. You could add 4 and square root, but most people only get one answer that way. I highly suggest you factor. And you find that you get x is equal to negative 2 and positive 2. Now here's where you have to be careful. If I let x equal 2 or negative 2, it forces division by 0. And I can't divide by 0. So when I write my domain for this one, I got to be very careful. Those are the only two values that cause trouble. What about 3? 3 makes a 0. but it's in the top, and I could care less about the top. I can only not divide by 0 and not take square roots of negative. So the domain is going to be like a polynomial. It's going to start at negative infinity. What's it go to, though? How far to the right will it move? Positive 2? It has to stop someplace.
Well,
There's no.
No, 2 with the little, is that the bracket? Don't you? Yeah.
What's the first number you run into? Negative 2. And it can't equal negative 2 because it'll make a 0 in the bottom. So I have to stop this thing at negative 2, bracket or parentheses. If I make it a bracket, I get a 0 in the bottom. I want to leave him off. Dump him. I don't want it equal to negative 2. I want all the numbers up to negative 2. Nothing, there. Where do I want to start again?
2 to positive infinity.
So you're going to skip all the numbers between negative 2 and positive 2? So I can't use 0? I need you to think about this in detail. Every little step that you make is very important. Can this not equal 0? 0 minus 3, 0 minus 4. Is that an illegal number? No, it's a perfectly fine one. It's called negative 3/4. So where do I start up again?
Negative 2 parentheses.
Negative 2 with a parentheses. You just jump over negative 2. I just don't want that one lousy little value. Where does it go to?
Positive 2 parentheses.
Positive 2 parentheses, union.
2 parentheses, positive 4, positive infinity.
Now you got the pattern. I need to jump over the negative 2. I need to jump over the positive 2. I can't include either of them. But it can include all the other real numbers out there, just not those two. Okay? Seems reasonable, doesn't it? It's just I like picking at you.
What if we forget the union?
If you just leave the union off, I'm not going to kill you. If you put commas in there, I'll understand it. But technically, put the union. How about this one? G of x is equal to the square root of 3 minus 5x. These are like one of my favorite ones. My favorite thing of all time is people get these things backwards. They'll say, oh, it can't equal to something here, and it can equal a lot up there, and it's usually the other way around. Fractions usually remove 1, 2, 3 numbers. Radicals usually remove negative values, which is 1/2 of a number line. So it's either pointing to the left or it's pointing to the right, radicals. These things just remove single values. All right, what is wrong with the radical?
It's negative.
I got to be really careful that I cannot take the square root of a negative. So what do I want 3 minus 5x to be?
0 or negative infinity.
What do I want it to be? What kind of number?
No.
I need it to be positive. It can't be negative, so I force it to be positive. So, need 3 minus 5x to be positive.
Yeah, that's where you need a negative for the positive.
How do I make it positive, though?
These 2 negatives equals a positive.
There's no product here. I know what you're saying. You're saying if I choose x to be negative numbers, this is guaranteed to be positive. But there's other numbers that actually make it positive that aren't negative. So when you say 3 minus 5x has to be positive, what does that mean in inequality language? You would write 3 minus 5x. How do you make something positive? What does it have to be bigger than?
It gotta be bigger.
Bigger than what? If you're a positive number, you're bigger than something. You're bigger than 0. So if I write, I'm bigger than 0, that's a positive number. This reads 3 minus 5x is positive. But it also can be equal to 0, because 0 is perfectly fine to take a square root of. Square root of 0 is, boringly enough, 0. So it's perfectly fine. So this is what's going to find my domain. You set up the inside greater than or equal to 0. Solve it. What do you do first? Stare at it, okay. You
Subtract 3.
subtract 3. So you get negative 5x is greater than or equal to negative 3. Then what?
Oh, negative 5.
Divide by negative 5. Any bells and whistles going off in your head? What's that do? I know that, but what does it do to my inequality? Flips it. So this becomes x is less than or equal to 3/5. So when I talk about the domain here, the domain is from where to where? Which way is that arrow pointing? As long as the x is first, it depends on where that arrow is pointing.
Negative infinity like this.
Negative infinity all the way up to 3/5.
Sorry.
Bracket. So there are a few positive numbers that work for this. Most of it is negative, but there's 3/5 to 0, they're all positive numbers, and they'll work perfectly fine for this function. So see the difference in their domains. This one removes single values. This one removes half of a number line. Always, unless it's a quadratic, but we'll deal with those later. We'll only put linear underneath a radical. Okay. So that's all there is to domain. If I ever ask the domain, these are the only two things you worry about. Are you dividing by 0? Remove those values. Are you taking the square root of a negative value? Remove those values. I don't know why people make this hard. It's actually pretty simplistic. It's two ideas put together. So then I can ask something silly like this. And this is not as easy as it looks. I think that's what I want. Yeah, that's what I want. Actually, I wanted to flip, but that's all right. We can do this. Okay. Will you ever take the square root of a negative number? So if x is equal to -4, I'll never take the square root of a negative number. -4 plus 3, square root of -1, I don't need it. So yes, there is a possibility that I'm taking a square root and it will become negative. Will I ever divide by 0? Yes, when x is equal to -3. -3 plus 3, 0. Square root of 0, 0, dividing by 0. So you have to take care of two things. This x plus 3 cannot be negative, and it cannot be 0. So what is it strictly? It can't be negative, and it can't be 0. The only numbers left are positives. So you say this has to be strictly positive. Now I like saying strictly positive because it don't get the equals like this last one did. This one is positive, but 0 is included in that kind of language. This is strictly positive, definitely get rid of 0. Solve it. This shouldn't be too hard. Oh,
Good choice.
thank you. It's not that hard, really. So you get x is greater than -3. So the domain of this function starts where? Starts at -3. Notice the parentheses. Why the parentheses? There's no equals. And we definitely don't want it equal to -3 because if it's equal to -3, we get a 0 on the bottom. So it starts at negative, just to the right of -3. And it goes off to infinity. There's a domain. Not that bad, right? Let's make it worse. Let's flip it. Let's flip it upside down. Do the same question. Let's talk about the domain of g of x. Notice the top over there didn't matter a lick because you could do whatever you want to the top. Now the top matters because the top has, well, a fancy little square root over it. Now that square root is not over the x squared minus 4. X squared minus 4 is all by himself. What do I have to worry about here? Well, I have to worry about the same thing. The square root cannot be negative, but is it strictly negative? No. So I can go from -3 to infinity. That doesn't change. So the domain has this piece already. -3 to infinity. That's from the top. That's the exact same thing as the bottom over here, except it can equal. What's wrong with the bottom?
Let's be greater than 2.
Just greater than 2. What can't happen with the bottom? It can't equal 0. Does that mean it's just greater than 2 and it's perfectly fine?
To
Or,
infinity and negative infinity 2.
okay, you're missing a value. We did this one earlier. Just a little while ago. Right there. So this one says, and x cannot equal -2, +2. Now, I need to take these two things and put them together as one answer. The top says I have to start at -3 and go to infinity. That's guaranteed. The right one says I can't have -2 and I can't have +2. Are -2 and +2 in this interval? Yeah, both of them are. I gotta get rid of both of them. So when you put them together, you get the domain starts at -3. Where does it stop? -2. Can't equal -2. I gotta get rid of it. So what do I put next to the -2? Parentheses, union, parentheses, -2, 2, parentheses, union, parentheses, to infinity. Now, this one over here had one interval. This one over here has 3. That's the danger of weird things in the bottom and weird things in the top. So that's a combination of both radical and division by 0. So you got to be very, very cautious. All right, that's just the minor topic. Let's go to the major topic. Well, one of the semi-major. Combining functions. Spelled it wrong already. I bet you've seen something like this in like 4th grade or something silly like that. Store A, Store B, and they sell milk, eggs, flour, and sugar. And Store A sold this. And Store B sold this. And the question is, if you own both the stores, how much milk did you sell? And your answer would be? If you own both stores, if you own both stores,
I thought
if you
that
own
was
both
0. My bad.
stores,
15.
0, that's a bad
I
store.
didn't see that. 1.
So, the idea here is, if you look at sales of Store A, milk is your domain. How many it sold is your range, right? That's pretty much what it is. If you look at the milk, you sold 5 units. And if you look at Store B, its milk sold is 10 gallons or whatever the heck it is. But when I said how much did they sell together, you said the milk sold for both the stores was 15. Well, I have to kind of give that a name because this is Store A and this is Store B. So if I make milk 15, what do I name it? A times B? Because if you write AB, it's A times B.
Oh, that's B.
A plus B. So you go off to the side, store A plus store B, the milk they sold is 15 altogether. This is the idea of what it means to combine functions. Now, if I added one more topic here, let's say, I don't know, what's an easy grocery that doesn't have a long word? Bread. There we go. Let's say store A sold 7, and store B did not turn in their report. They didn't send in how many bread they lost it, someone had caught fire, someone stole it, whatever. They don't have information, and you can't put 0 because obviously they sold some. You just don't know how many. So if I write this, and I go to my stockholders or whatever, and I say, well, both of my stores sold this much of bread. Am I going to say 7? I'm going to say I don't know, because one of the information was missing. So when I get down to bread as a domain, there's nothing I can put in the other slot, because I can't talk about both of the stores. I can only talk about store A. Does that make sense? So because store B doesn't have anything in its domain for the bread, I can't use it as a combination of the two stores. So if the domain is missing in one of my functions, I can't use it for a combination of both of my functions. And that's a key point. So domains must match. That's probably the most important part of combining functions. Your domains have to match. And the best way to match them is to take them and intersect them. Find out what's in common. If I intersected the domains of these two, milk, eggs, flour, and sugar would intersect, and bread would not be part of it because there's nothing there in common. So it would have just the 4 units of measurement, and the bread would just get dropped off completely. Off the report, disappears, doesn't even count. So your domains have to match, and that's by intersection. So if f has a domain of -infinity to 3, and g has a domain of 0 to infinity, and I want to come up with a function f plus g, what would its domain be? Pick a number. -5. -5 works perfectly fine for f, but it doesn't work for g. So -5 is not in the domain of f plus g. So where does the domain start? It starts at 0. It's in here. 0 is in -infinity to 3. 0 is definitely the beginning of this one over here. So it starts at 0. Can I use 7?
No.
No, because it's not in f, but it is in g. So where does it stop? And that's what I mean by the intersection. What do they have in common? This one starts at 0, stops at 3. That's all they have in common. Nothing bigger, nothing smaller. So if I ever compose these imaginary functions together, I can only talk about them from 0 to 3. It's a little weird, but that's okay. It's not -infinity to +infinity, I'll tell you that much. What'd you say?
Right
No, it was not even close. I think that's what you said. I just didn't want to listen to you. For example, if I have f of x is equal to 2x minus 3, and g of x is equal to x squared plus 5. Before I even start these things, I usually start with what's the domain. So the domain of f is what? Don't you dare look back. Domain of f. Are you ever going to divide by 0? Are you ever going to take the square root of a negative number? So what's the domain? All real numbers. -infinity, +infinity. Domain of g.
All real numbers.
All real numbers. I'm never going to divide by 0. I'm never going to take the square root of a negative number. So if I combine these with addition, the domain would be the combination of both those intersection, which would be all real numbers. Okay. So now the next thing is notation. I want to take my two functions and I want to add them together. But F and G are Frank and George, so Frank plus George means absolutely nothing mathematically. So I got to kind of change it into function language. So it starts off this way. The new name is Frank and George. They're going together to the movies. I don't know. But they're going to use x's. So instead of f of x or g of x, this becomes known as f plus g of x. But this notation is ridiculous because you don't know what to do with Frank plus George. It doesn't make any sense because Frank and George up above are separated. So the way you deal with it is this. When I was doing store A and store B and I wanted to find out how much milk both stores sold, did I change milk? No. I just took their two ranges and I added them together. So the same thing happens here. You take your range. What's the range of f? I know it's not negative infinity to infinity, by the way. That's the domain. What's the range of f? Well, the range of f is f of x. Remember, f of x is y, right? You know, x is on the inside, y is the whole thing. So the range of f is f of x plus the range of g. Well, what's the range of g then? G of x. It looks like, a lot like, the distributive property. It is not. It is just describing what's going on. This new function f plus g is going to work on x, and the way it works on x is you take the function of f evaluated at x and you add it to the function g evaluated at x. And you get this new y value. So the first thing you do when you see this notation is separate it. F of x plus g of x. And then plug in your functions. What's f of x look like? So you get 2x minus 3 plus g of x. What's it look like? X squared plus 5. And you get this new function. And it looks like f plus g evaluated at x is equal to x squared plus 2x plus 2. Can I see if it works? I'm worried now. She's looking at it like, where the hell did you get that from?
Yeah,
X squared
yeah.
plus 2x plus 2. Remember, distribute the ones that are sitting in front. The parentheses basically drop.
Okay.
And you can combine like terms and put it in order. All right, let's experiment. What's f of 2? F's up here. What's f of 2? Whispering again? Oh, 1. What's g of 2? Is only one person going to whisper in this class? And notice I didn't say answer. I said whisper. 9. Okay, 2 squared plus 5. All right, what is f plus g evaluated at 2 by this method? Well, it's f of x plus g of x. So it would be 1 plus 9, better known as 10. All right, so that would be 10. Now, if I use this function to evaluate it, f plus g of 2, I would plug 2 into the x's here and get 2 squared plus 2 times 2 plus 2. 4 plus 4 plus 2. 10. You get the same answer. So I've come up with this new function that'll take the two answers that they originally give you, add them together, and generate the final answer in one fell swoop rather than two separate ones. Does that make sense?
Mm-hmm.
Sort of. See, individually I came up with their answers and added them together. Secondly, this one just says do the calculation with 2 ones.
So it doesn't matter which one you
But I want you to come up with this one.
do? Okay.
Because I'll be asking for what's f plus g of x, and it's x squared plus 2x plus 2. I'm just showing you down here that it actually works.
Okay. I got you.
Okay.
We'll time that. I'll run it.
No, I'm serious.
Now, you can do f minus g of x, f times g of x, and f divided by g of x the exact same way. F minus, you put a minus in between them. F times, you put a times between these two right here. This f plus g of x, this would turn into minus times divide. The only problem is if you have division, let me write this one out. This becomes f of x divided by g of x. What's wrong with that one? All the other ones don't cause me any trouble at all. This one causes me just a little bit. What is wrong with a rational setup? What are the two things you can't do? You can't divide by 0, so g of x definitely cannot equal 0. So when you get this case, there's a little add-on. G of x also cannot equal 0. So the domains of both of them, but then you have to be really careful that g of x can't be 0 at all, because you're dividing by it. Alright, let me show you the nastiest example then. For example, well, not the nastiest. Let's go simplistic first. F of x equals that, g of x equals that, and I want to do some combination with them. But even before I get to the combination, I want to know the domains. So, what's the domain of f? No, that's not an answer.
Right.
What about it?
Three to positive infinity.
Just 3 to positive infinity?
Well, 3 to positive infinity, and then
See, you're thinking radicals. Is this a radical? No. What do I have to worry about? The bottom equaling 0. When's the bottom equal to 0? 3.
positive
Right.
Yeah.
So what numbers can it
Oh,
be?
so negative infinity 3, and then 3 is negative positive infinity.
But it's not just one direction, it's both directions. You're just jumping over to 3. What is the domain of G then?
Negative infinity, negative 2, 2, and negative 2.
There. Jumping over. Okay. I want to find. What do I want to find? Let's do minus g of x. Now, if I'm trying to find f minus g of x, the first thing I write to the right of this is. This makes absolutely no sense to anybody. Change it to it makes sense. F of what I do over there. I took f plus g of x on this side, and I changed it to this on the other side. Well, I wrote f of x plus g of x over there, but f of x, y plus.
Minus. I don't know, for some reason I was thinking opposite.
Minus. Why would I change it? You try to make math hard. You really do.
know.
You are an expert at making things. 2 plus 2, oh my god, this must require calculus. So, what's f of x look like in this case? Well, 2 over x minus 3. Minus, what's g of x look like? 4 over x plus 2. Create one huge ugly fraction out of this. How do I do that? And the common denominator, well, I can't multiply that common denominator. I need to get a common denominator. I can't do anything to the other side. So what do I multiply this side by? X plus 2. If I put it in the top, now if I put it in the top,
You gotta put it in the bottom.
I better put it in the bottom. I'm getting a common denominator. I'm not multiplying by the common denominator. What's this side missing? X minus 3. If I put it in the bottom, you better put it in the top. Right. Now we have a common denominator. Specifically, x plus 2, x minus 3. You only need to write it once. you want me to explain why you only need to write it once? Because they're exact same denominator. It's the distributive property. You all know that, right? Adding fractions is the distributive property. I thought I taught you this at the beginning of the year, didn't I? Could have sworn I did. You're lying to me. 3/5 plus 1/5. Since they have a common denominator, you can write this as 1/5 times 3 plus 1/5 times 1. Factor out the 1/5. What's left behind is 3 plus 1. You get 4/5. So, it factors out, you did it once. What's left in the top?
2x plus 4 minus 4x plus
2x plus 4 minus,
4x plus 4.
and this is why I get mad at you.
What?
It's negative 4 times x, which
Yeah,
is
that's
negative
what
4x.
Yeah, that's what I said.
And
Minus
it's
4x
negative
plus
4
my
times
bad.
negative 3. It's that second one that causes errors. Gotta be careful. Plus 12. Bye.
It's only Monday.
Yeah, I ain't sure.
It's only Monday.
Yeah, be careful.
And we get all next week off, and you're gonna come back, and all your brains are gonna be like, oh.
Friday.
I'm glad.
Right time.
1 plus 1.
I'm glad
3.
I'm out of your house.
Alright, simplify. This becomes negative 2x plus 16 over x plus 2x plus 3. You can factor out a negative 2 in the top, but I don't think it's going to help you any. It'll leave behind an x minus 8, and it's not going to cancel with anything, so you might as well just leave it alone. So, f minus g of x. What is the domain of my new function without even looking at my new function? If you didn't look at this, and you only had this to go by, what would be the domain of my new function? Well, this one says it can't be 3. This one says it can't be negative 2. So this one better be, it can't be 3 or negative 2. I'll write that simplistically. I'm running out of room. X cannot equal negative 3, positive 3, negative 2. That's the easy way of writing it. So that would be the domain of this new function. Now it's break time, because my throat is sore. I'm tired of yelling at people.
Yeah, all right.